Okay, quiet, please. Okay, no. Number one. So a few people got this right. And for the most part, not the way you were probably expected to attack it, but there are different ways you can go about this. What you should be seeing at this point, instinctively, is that that's a factoring problem, right? There's cotangent of x in both terms, and without even putting a pencil to paper, you should be able to see that if you take away the cotangent, that what would be left? Peter. If you take away the cotangent, what's going to be left? Secant squared minus 1. Okay, perfect. That's an identity. Right? What most people did is substitute here for 1 plus tangent squared, and then maybe make that into a 1 over tangent and that into 1 over tangent, which can work, and some made it work. But the reality is that that's probably intended to be more of a factoring problem, and the reason we don't get it is we're not a factor. That's not a trigonometry problem. That's an algebra problem. That we still, when we get to things like greatest common factor factoring, are just stumped. Pretty much like we were in Algebra 2. Because in Algebra 2, we would do a lot of time doing things like factor, let's say, x squared minus 5x plus 6. And people get fairly proficient at that. And maybe they get a little less proficient at, what is this, plus 3? Yeah. At that, because I got to multiply by 1. And then maybe we learned a little bit about difference of squares. X squared minus 25. And then we put in something like x squared minus 2x, and everybody goes, I don't know what I'm doing here. What are we supposed to do? Greatest common factor. You take out the x. That's supposed to be the easy kind of factoring. And if you don't get that, it's obvious you're not going to get things like this. Okay? It's obvious. And you're going to have a hard time in calculus, too. If you can't do things like that, we're intended to be an easy factoring problem. That's just where we're at. Right? Cotangent of x times secant squared x minus 1 equals tan x. Right? So that's cotangent of x times tan squared of x. And the identities were on the board, so you had all of them. All right? And so this cotangent is 1 over the tangent times tan squared. So this one cancels one of those, tan x. Okay. All right. Now, some somewhat common mistakes is like on this next step, you did substitute for 1 minus tan squared there, but you didn't put parentheses around that. So it's like you had a 1 minus tan squared times cotangent x, but it wasn't that the cotangent of x is also multiplying times the 1. I mean, you've got to have parentheses around that, or it's going to be wrong. The next one was a harder problem. Myself, when I did it, I thought, well, I know that I can turn these into sines and cosines, and maybe something will happen with the denominator. So first step, let's do that. 1 over sine theta plus 1 over cosine theta. Right, divided by sine theta cosine plus cosine theta. Right, now, in order to add those two, you need a common denominator. So what am I going to multiply the first one by? Yeah, I'm going to do a purple. So we'll multiply this by cosine over cosine, and this one by sine over sine. So now we have the same denominator, sine theta, cosine theta. And in the numerator, we have sine theta plus cosine theta. And then still in this denominator, we still have a sine theta plus cosine theta. Okay, well that's just what I need because the sine plus cosine is going to cancel, right? That this cancels this. And all we're left with is 1 over sine theta cosine theta. Okay, so I'm looking at that going, okay, well, I'm still not there. And I'm not sure how I'm supposed to go from this one term to these two terms. Okay, let me work on this side and see if I can make it look like that. Right, this one is cosine over sine. And the next term is sine over cosine. And again, find a common denominator. Right, what will I multiply the first one by? Cosine over cosine. And the second one? Sine over sine. So it just turns that cosine into cosine squared into sine squared. So now we have sine squared plus cosine squared in the numerator. And sine theta cosine theta in the denominator. Okay, well the numerator is 1, right? This whole thing is 1, which is that. Done. Okay. Okay, find all the solutions. Now, first thing, the last thing you want to do here is start distributing that. You've got something that's in factored form equals 0. That's exactly where you want it to be. Plus, we don't have any way to do this. We don't know how would we multiply a tan of 3x times a tan of 1x. We don't have anything to do that with. So don't distribute, use zero product property, right? Set each one of these equal to 0. Now, do you remember what you call it when you've got a 3 in front of the x there? It's a multiple angle, right? It's a multiple angle. Okay, so this is, we set tan of 3x equal to 0. Okay, here's what you can't do. I'll do it in red because you can't do it, right? You can't divide a 3 there. That's not how we deal with that. You cannot do that. A lot of people either showed that step right there, or they showed the very next line said tangent of x. So you just say, I'll just get rid of it. It's just tan of x. That's not how we dealt with that. You can go back and look at our examples and the homework problems, and I don't think anybody did it correctly. Maybe one out of, you did? Maybe one. Dan did. He still doesn't do his homework, so I don't know. Remember, this is how you do it. You look at the tan of 3x and say, where does tangent equal 0? Don't worry about the 3x. Where does tangent equal 0? Tangent equals 0 where sine equals 0, because it's sine over cosine. Where does sine equal 0? 0, pi, 2 pi. Basically, you would say it's 0 plus n pi, right? Which you don't need to put the 0, so we'll just say at n pi. So you would say when 3x equals n pi, then this thing equals 0. Okay, now divide by 3. Right there, now is where you divide by 3, not inside the trig function. So x equals n times pi over 3, like that. And this part we set equal to 0, which means the tangent equals 1, and that means x equals, where does tangent equal 1? Pi over 4, right? And yeah, and what's the period of a tangent? Pi. So you say plus n times pi, not n times 2 pi. Okay, pi. So those two together are the answers for that. Okay, solve. This time we've got a domain that says only from 0 to 2 pi. So let's see. Most people did exactly what we said to do, which is get everything on one side, 0 on the other, factor. Why do we say to do that? Why do we say that instead of dividing by cosecant of x? But, however, comma, yeah. In this case, you could have gotten away with dividing by the cosecant because it doesn't have any zeros. Remember the graphs, right? So most people did this, and this is fine. You're going to say secant of x, cosecant of x, minus 2, what happened there? It's my x. 2 cosecant of x equals 0. And then factor out the cosecant. Cosecant of x times secant x minus 2 equals 0. Okay, now at this point, if you apply the zero product property, you say cosecant of x equals 0, and then you say no solutions because there are none. Oh, this pen's not going very well. Right, this part, when you set it equal to 0, you get secant x equals 2. Okay, now you got to think, yes? I'm showing what people did on this, okay? If you did go through these steps at this point, you would come to that point and say, no solutions. Okay. Now, secant x equals 2, you should switch that to a cosine, right? If you flip both sides, you're going to get that the cosine of x equals 1/2. Right? Secant is 1 over the cosine. Now, we had that. We did that kind of flip in the homework on that section. So it's not like you hadn't seen that before. You get to a secant equals 2 or a cosecant equals 2, then you should know to flip them, because that we recognize. Where does cosine x equal 1/2? Right? Remember, 1/2 is the shorter coordinate. That means you're right there. Right? That's pi over 3. Right? Meaning the x is less than the y. So it's right there, and it should be straight down. So what is that? 5 pi over 3. Okay, and then the last one. True. I mean, it's true. That is what, that's just the convention is to write it there, but it means sine x squared. So in second block, this is the problem they got. They got sine x squared equals sine squared x. That's false. Well, it's got parentheses there. I did that in case anybody talked to somebody in second block and said, the last one is false. The last one is false. No, that's true. This is the sine of x squared. Right? This is the sine of x squared. Right? If somebody tried to just pass along the true-false question like that, then you would have gotten it wrong. And I will say, I think at least half got that question wrong here. And in their class, not half got that question wrong. The majority got it right. Okay, so the study guide is going to be this. And I'm going to go through each group of problems just to show you what's going to be on the test. Okay, I'm going to give you all the formulas you need, right? But not the unit circle. You have to know the unit circle. Okay, ready? If you want to write it down, go ahead. If you're going to write it down now. I'm not going to leave it up more than a minute. Yes, everything will be posted and emailed and everything like that. If you look at the fundamental identities, let's see, the sum and difference formulas, have those. What else is there? Double angles. if I don't give you the half angles because you don't need it, I'll give you the ones you need. That might save you from using the wrong one. You know, oh, look at this sum to product thing. I think I'll try that. Guess what? There's no problems that use that. We good? Dan? Anybody? Jasmine? Okay. So the first set of problems is coming from the section that was just simplify, factor and simplify. And, you know, it's kind of like the first question on the quiz where you had to factor, and there might be some simplifying. Like on the first one here, what would you factor? Tan squared, right? What would be, if you took a tan squared from both of these terms, what would be left? 1 minus sine squared. What does 1 minus sine squared equal? Cosine squared, right? That's the kind of thing you're looking for. What about this 23? Okay, but look at the other side of the fraction. Before you decide you're going to make it into a tangent. Why would you turn it into a tangent when you got a secant x? Okay, what kind of factoring are you going to do in the numerator? It's a difference of squares. Secant x plus 1 times secant x minus 1, which cancels the denominator. No. Okay, so that's the kind of thing. Same thing over here, right? You would have said cosine x plus 2 times cosine x minus 2. Cancel them. Right? Even this is a difference of squares. Right? Secant squared plus tan squared, secant squared minus tan squared. Okay. These in the study guide, 29 to 32, are intended to be quadratic types. So you need to know how to do a quadratic type of factoring. Right? So 3 times negative 2 is negative 6. The factors of negative 6 that add up to negative 5. You know, go through that process. It's just that now you've got sine x as the first term in each factor. And what if you have, like here, a mix of functions? Like here's a sine squared and a cosine to the first. What are you going to do to fix that? Peter, take off the glasses. What are you going to do to this one so that it's all the same function? It's not that hard of a question. You cannot do that. You can say the sine squared is 1 minus cosine squared so that it's all cosine. Okay. So that's the intent of that group of problems. There'll be a quadratic type. Okay, there will be some adding or subtracting of expressions. Add or subtract, simplify. So basically you have to find common denominator, right? So what would you multiply the first term here by? 1 minus cosine over 1 minus cosine. What would you multiply this one by? 1 plus cosine over 1 plus cosine. What would your denominator be at that point? No, it's not an equation. It would be 1 minus cosine squared, which is sine squared. Okay. So you need to know how to find a common denominator with these and simplify. What'd you multiply this one by? Tan over tan, right? You need a denominator of tan, multiply by tan over tan. Simplify. Now, when it comes to the identities, there's just, on that page, I just put all these problems on there. You know, if you're doing it for the study guide, you should just don't pick the first two up here that are obviously the easiest ones. Pick a few, mix through. If you look at, there's more after 40, but they have some square roots and absolute values and stuff that we didn't really ever do one like that. So you don't want to go too far in these problems. But most of these, we should be able to deal with. What kind of substitution do you have to make when you see pi over 2 minus theta co-function identities? And you'll have those to look at. What kind of substitution do you make when you see a sign of a negative angle? Even and odd, right? So the even and odd identities. Okay. So you try a few. Now I'm probably gonna. I don't have really copies to give out, but I'm gonna post on the website a bunch of verify identities with all worked out. Okay. Somehow I got it from somewhere last year, and I can send it if you want to look at it. Okay. Then we get into the solving of equations. And the first group of problems here is intended to be just a fairly basic, like if I subtract the square root of 3 over here, you have to look for where does tangent equal negative root 3, right? Or, this one you would have to subtract sine x, then you'd have 2 sine x plus 1 equals 0, which will mean sine x is negative 1/2. Okay, where does sine x equal negative 1/2? So this is intended to be on the easier side of the solving equation stuff. What about this one here? Let's say we did that one. Right, we isolate the cosecant. The square root of 3 cosecant of x equals 2. Cosecant of x equals 2 over the square root of 3. Tanner? Flip both sides. Sine x equals root 3 over 2. And that you should recognize, right? Where does sine equal root 3 over 2? Remember that if you're solving one like any of these here, when you take the square root, guys, when you take the square root, remember the plus or minus. You're not going to get all the solutions. What's that? No, that was a stray mark. So remember to take square root plus or minus. Okay, then we get into a little more difficult problems where maybe you're going to have to bring across the tangent x and then factor, use zero product property, more quadratic types in there, factoring, secant x plus tan x equals 1. I imagine you'd probably 1 over cosine, sine over cosine, something. So you should make sure, take a few from the first, but make sure you take a few from here too to practice. And then those are the multiple angle ones. Let's do one of these just to do. Okay, how about 42? Secant of 4x minus 2 equals 0. So secant of 4x equals 2. All right, what do you think I should do with that? Flip it. The cosine of x, cosine of 4x equals 1/2, right? Okay, so again, how do we deal with this at this point? Do I divide by 4 inside the function? No, what do? I say, Chloe? Figure out where 1/2 is on the unit circle. Cosine equal 1/2, okay? So where is that? Pi over 3, 5 pi over 3. Okay, so I would say 4x equals pi over 3, and then I've got to put something on the end of that. Plus 2n pi, because the period of cosine is 2 pi. Okay, and then divide by 4, right? X equals pi over 12 plus n pi over 2. That's 2 divided by 4. And then do the same thing for the 5 pi. Right? That would be 4x equals 5 pi over 3 plus 2n pi. Divide by 4. X equals 5 pi over 12 plus n pi over 2. Okay. So make sure you do a multiple angle one. All right, then we get into the sum and difference formulas. And you're gonna get one. I think the directions are the same as this. Find sine, cosine, and tangent of an angle which is not a unit circle angle, which you're supposed to use unit circle values which either add or subtract to give you that angle. And you'll be given that part of it. Okay? You'll be given like this, where it's telling you 7 pi over 12 is pi over 3 plus pi over 4. So that part you know. Now you need to use the formula for the sine of a sum, and the cosine of a sum, and the tangent of a sum, which you have. Okay? Is it clear? Did that go? No. 17. You know, the drawing triangles one, right? If it says the sine of u equals negative 7 over 25, and the cosine of v is negative 4 over 5, both are in quadrant 3, right? You need to know which quadrant to be in. Then find all this stuff here. So let's see, which is a good one to do. How about we do a cosecant of u minus 2? We haven't seen one like that. Let's set up our triangles. We're in quadrant 3 for both. So make sure when you're drawing triangles that the terminal side starts at the origin and it goes out into the quadrant in question. And then you make a right triangle, right? And that the angle is with the x-axis. So u is here, v is here. Negative 7 over 25, that's a sine, so negative 7, 25. And negative 4 is cosine, negative 4 and 5. And 5, negative 4, this is negative 3. How about this one? 25, negative 7, 625. Okay, so now let's see. If we're going to do the cosecant of u minus v, the thing is we don't have a formula for the cosecant, so what are we going to do? 1 over the sine, right? So 1 divided by the sine of u minus v. So let's do the sine of u minus v is sine u cosine v minus cosine u sine v. And all that we can plug in, right? That's going to be the sine of u was negative 7 over 25. The cosine of v is negative 4 over 5. And the cosine of u, that's this triangle now, so it's negative 24 over 25. And the sine of v would be this triangle, that is negative 3 over 5. Simplified. Okay, so that is going to be positive 28 over 125. Minus positive 72 over 125. Which would be 1 over 28 minus 72. 42, 44. Negative 44 over 125, which is negative 125 over 44. So draw the triangles. Use Pythagorean theorem for the third side. You got the formulas right in front of you. And then, let's see, prove the identity. So there'll be something to prove using sum and difference formulas, prove the identity. Now, if you're given something like this, okay, it says prove that the sine of pi over 2 minus x equals cosine of x. You can't use this identity to prove itself. Okay, that means you're going to have to use the sign of a difference and show how it equals that. Okay, don't just say, oh, well, by this identity, this equals the cosine of x. One step, I'm done. It means you're going to have to use something else. Right? And when they say prove the identity, I mean, it's really verify the identity. I mean, that's the way we talked about it in earlier parts of the chapter. Here they say prove. There's probably a good reason for it, but I don't remember it. Okay, and then solve an equation using sum and difference formulas, which you'll have. Remember, when you do one of those, let's say we do the number 70 right here. We use the formula. For the cosine of a sum, that would be cosine x cosine pi minus sine x sine pi minus cosine x minus 1 equals 0. At a certain point, yeah, I saw somebody was doing this, and they interpreted like this was in parentheses and tried to do the cosine of a difference with that. But that is not inside. If it was, it would have parentheses around it. Okay. And then when you get to this point in these kinds of problems, there's always some simplifying just to say, well, what is the cosine of pi? We know that. -1, right? And what is the sine of pi? 0. So that whole term goes away at 0. And what are we left with? Negative cosine x minus cosine x minus 1 equals 0. Which should look pretty familiar, right? This is going to be, if I move that to the other side, it'd be a positive 2 cosine x equals -1, cosine x equals -1/2. Where does cosine x equal -1/2? Right, negative means it's over here, so right there and right there. 2 pi over 3, 4 pi over 3. And then we get to the double angle formulas of the last bunch, right? So find the sine 2u, cosine 2u, tan of 2u using the double angle formulas. So you just have, it's telling you which quadrant that you're in. So draw the appropriate triangle, use the formula. Right? What if we did, we're going to use this one to death here, right? If we did the secant of u. That's it. Secant of u equals -1/2. How am I going to turn that into something that I can draw my triangle with? Flip it, so it's the cosine of u equals -1/2. And which quadrant are we in? Between pi and 3 pi over 2. 3. Right, so this is quadrant 3. So draw your triangle, quadrant 3, right? Label the u here. Its cosine is -1/2, so -1/2. Pythagorean theorem time. What is this? Okay, 4 minus. And then just plug them in the formulas. Okay. And the last, I didn't put it on there, did I? So I think the extra credit will be verify one of these. I mean, use the sum and difference formula. Use the sum and difference formula. See how that simplifies and whether you could make that equal that. How hard is that? Oh, please. How hard could it be? You want to do one? Watch. That's a minus, parentheses, sine u cosine v minus cosine u sine v. Okay, that equals 1/2 sine u cosine v plus cosine u sine v minus sine u cosine v. Now minus times minus makes plus cosine u sine v, right? I just need the bracket now. Okay, let's see. This term and this term cancel, right? And then these two are the same, so that is 1/2 times 2 cosine u sine v. And the 2's cancel, done. What did it take? 1 minute? It should not be that hard. Okay.